Last episode, we basically built the Hawk with high-torque actuators. We gave the robot Superman strength. But ask yourself, would you trust the 300-pound metal giants to hold this? Or this? One wrong move and it will be a disaster. So how do we turn this Hawk into a nanny so it can actually live in our homes? How do we give a machine with Superman strength the gentle touch of a mother? To make it concrete to understand, let's try this diaper test, which means changing diaper for a little baby. To pass this diaper test, it all comes down to solving 4 massive problems. First, the touch. How does it know exactly how much pressure to use without crushing the target? Second, the vision. How can it find these tiny sticky tabs in a pitch dark room? And third, the juice. Where does the energy come from so it doesn't die in the middle of the mission? And finally, the body. How can it be tough as nails but light as a feather? Let's start with the touch. Now think about when you picking up an egg. How do you know not to crush it, but also not to drop it? You feel it, right? Skin sends feedbacks to your brain, and robots need this too. We call them torque sensors. They act like digital nerves in the joints, constantly measuring, am I grating too hard? Or is it the hard edge of the grape or a soft baby skin? It allows a robot to feel resistance, turning a steel clap into a gentle hand. System 2, the vision. Touch isn't enough. It also needs to see, even in pitch darkness at 1 a.m. You know how bats use echolocation to map their surroundings? LiDAR does the same thing, but with invisible laser pulses. Pew pew pew. It builds a 3D map instantly, just like CT machine in the hospital. So even if you are half asleep or the lights are off, a robot can find these tiny sticky tabs on a diaper without bumping into the furniture or waking the baby. System 3, the juice energy density. Alright, now the robot can see and feel. But imagine this, the diaper is half off and the robot just freeze, battery dead. You might think, it's just a battery, what's a big deal? Now here is a big deal. A humanoid robot is an energy-hungry beast. It has dozens of motors running simultaneously, working, balancing, and gripping all at once. The power consumption is massive. Now think of a mountain climber. They carry all the food and water on their back. If the energy bar's battery are heavy and low capacity, they will collapse halfway up the mountain. Humanoid robots are those climbers. They need batteries that are light enough not to slow them down, powerful enough to last hours or even days, and safe enough not to overheat. Whoever solves the battery problems unlocks the next level of commercialization. Because, let's face it, who needs a robot that needs to recharge every 30 minutes? That's not a helper, that's a liability. System 4, the body. Lightweight materials, the skeleton. To move gracefully around a baby, the robot cannot be a lumbering giant. You might think, well, robots need to be made of steel to be durable, right? Yes, but also no. Imagine strapping on a 100-pound suit of armor. You've already exhausted just lifting your arms, and forget about being gentle with the baby. Same problem with robots. If the robot's body is too heavy, most of its energy goes to just carrying itself. That's why modern high-end robots use space-age materials like aero-grade aluminum alloys or specialized engineering plastics. The goal is to build a body like a taut ballet dancer, light as a feather in movement, but strong as steel in structure. Only then is it safe enough for our homes. So let's look at the full picture. To pass the diaper test, we took the powerful joints from last episode and gave them sensor and LiDAR for gentleness, battery for endurance, a light skeleton for safety. Now combine this, you finally turn the mechanical Hawk into a gentle nanny. Perfect, right? Wrong. It is still useless if it costs $1 million. So how on earth can Elon Musk promise to sell this for like...
At scale, this would cost something like, I don't know, $20,000, $30,000. Probably less than a car, is my prediction long term.
Is he bluffing, or does he know something that we don't? Now, next episode, the commercialization challenge. If you think this video is helpful, please hit subscribe. And I'm Cici. See you in the next one.